It's really good to be here. Thank you, Larry, for inviting me. My dad was a pastor, and I know it's really a big thing for a pastor to let someone else speak. So I know, this is a big thing. And I know for you, I appreciate you coming. I'm sure the first thing that came to your mind when you got up this morning was, I just haven't heard enough scientists talk recently, so I really want to go hear another scientist talk. And so, I know how that is. So I like to thank you for coming and listening to what I have to say. But this is an important concept, the question of whether Christianity and science are in conflict or in agreement. And we live in such a scientific culture that in many cases think that the answer is that these are definitely in conflict. So I want to talk about that over the next 3 weeks. We'll cover various aspects. Let me give you a little bit about my background. As I said, my dad was a pastor. So I grew up hearing stories of the Bible. In fact, on Sunday afternoon at lunch, we used to critique his sermons all the time. And so maybe that's another reason I'm speaking, so I won't be critiquing your sermons. But I went to a Christian college, Biola University in Los Angeles. I did my graduate work at UCLA, and then postdoctoral work at the Stanford Linear Accelerator Center. So I'm originally from California. I moved to Oklahoma about 20 years ago. And then I now do research at CERN. So I come out to this part of the world probably 3 or 4 weeks during the year. Spend a lot of time traveling over here. Many of you may not know where Oklahoma is. Me being from California, I didn't know where Oklahoma was till I moved there. But it's right in the center of the states. It's just north of Texas. Texas is our rival in sports, and we lost a football game last night. It was very disappointing. I don't know why I stayed up to watch the game, but I did. All right. So anyway, that's what we're going to talk about. I now do research at CERN. You may know a lot about it. You may know nothing about it, except that it's got the big ball out front. But this is a place where literally people from all over the world come to do research. It's the premier particle physics lab in the world. I spend my research studying the smallest structure in the universe. So here's the physics lesson for today. Most of you may know this, some of you may not. So I study the smallest particles in the universe. The physics lesson for today, most of you know the universe is made of atoms, and at the core of every atom is something called the nucleus. The nucleus is made of neutrons and protons are made of quarks. I've spent 30 years of my life studying the properties of neutrons and protons and quarks. So suppose you wanted to know what your car was made of, but you didn't have any tools to take your car apart. What would you do? No screwdrivers, no wrenches, no pliers to reach in and figure out how it works. Well, here's what you would do. I tell my students, do this with your parents' car, don't do it with your car. You get the car going really fast, and you smash it against a brick wall. And when it hits the brick wall, it breaks into smaller pieces. So this is what we do at CERN. There's a tunnel that's 27 kilometers around. We get protons going nearly the speed of light, and we smash them together. And the tunnel goes, pretty much under cities like Ferney-Voltaire and other places. It's about 100 meters below the ground. Inside the tunnel are these big superconducting magnets that bend the protons as they move underneath the Earth at nearly the speed of light. And then at a couple places, we actually build these big detectors. And so we can see the particles as they smash together and see the debris from the particles and what the universe is made of. The detector I work at is called Atlas. It's huge. You can see people drawn at the very bottom and the very top there. And so this is a gigantic detector, and protons come in from 2 different sides, smash together. The computer takes pictures like this. And then I spent 7 years of my life as a graduate student and 7 years as a postdoc trying to understand pictures like this. And that's what we do. So it's kind of fun. If you've never taken a tour, yeah, I know, it's really a waste, right? I mean, yeah. If you've never taken a tour of CERN, you should go there. In Oklahoma, people think this is really an exotic and exciting place to live and work. And I say, I'm going to Geneva to do work, and they say, oh, wish I could go with you. And I say, yeah, you should see the inside of the lab. That's what I spend most of my time seeing. It's quite fun. And so that's what we do. All right, let's talk about something other than CERN and particle physics. Let's talk about something that's important. Well, that's important too. But a lawyer once came to Jesus and asked this question. An expert in the law tested him with this question. Teacher, what's the greatest commandment in the law? It's a pretty important question, wouldn't you say? Out of everything that's ever been written, what is the greatest commandment of all? And Jesus' answer to him was this. Jesus replied, love the Lord your God with all your heart, and with all your soul, and with all your mind. I think it says, and with all your strength, too. I better look that up. All right, so anyway, but that's the greatest commandment. If you want to be a follower of Christ, you need to be all in. You need to come in with your heart, and with your soul, and with your strength, and with your mind. Now, a lot of times we worship God with our heart. We sing praises to God, and we feel uplifted. But we don't always think about this idea of worshiping God with our minds. And what does that mean? Well, for me as a scientist, I have to worship God with my mind. My mind is a big part of who I am. It means that I have to be able to ask tough questions about my faith and my Christianity, and there should be good answers for those. It means that I have to be able to, think through the issues of Christianity, and that I can't just check my mind at the door when I walk into church. I can't spend 5 days of the week studying particles and thinking, and then, Sunday, let's check that at the door. And yet there is this perception sometimes that you can't be a thinking person and be a Christian. Now, that's not always been the case. Some of the great scientists of history were Christians, people like Isaac Newton and James Clerk Maxwell, Michael Faraday and Blaise Pascal. These are people who both did great science and also investigated and then wrote a lot about Christianity, particularly Pascal and Newton. But those pictures are old, right? They're black and white, they're paintings. And you might ask, in today's world, where we have things like super colliders and space telescopes, is it still reasonable to be a person who's thinking and has faith in God? Can you can you love God with your mind during this time? And that's the kind of things we're going to be talking a little bit about. So we're going to answer these kinds of questions. Have scientific discoveries made belief in God unnecessary? There are certain people who think that they have. Isn't science based on objective evidence and faith just based on subjective feelings? There's a whole way of thinking called non-overlapping magisteria developed by Stephen Gould, or NOMA, that says these two are separate. If you want to be, a thinking person, then you have objective evidence, and that's science. And faith is okay, but it's not really based on anything concrete. Is that true or not? Can you be a thinking person and believe in God? Can you ask tough questions? Are there good answers to very difficult questions? And then, aren't Christianity and the Bible in conflict with recent scientific discoveries? I know in the States this is a big issue. Many Christians are almost afraid of science, thinking that some of the things that science has discovered are in conflict with what the Bible says. And that's kind of that fourth question we'll kind of focus on next week a little bit. Right? Now, these questions may or may not interest you. A person that's near and dear to my life is my mother, and she doesn't care about any of this stuff. She goes, yeah, Mike, that's good for you, but I have more important things. Or actually, it's different for her. Her faith in God is such that these questions don't impact it. But for some people, they do. So maybe these questions will impact your faith in God. Maybe they don't. But you probably have a friend, particularly in this area of the world where people from all cultures and the crossroads of the world come to Geneva, right? Scientists at CERN are literally from all over the world. So you may have a friend or a colleague or family member who this subject will interest them, even if it doesn't totally interest you. And God says you need to be aware of those people. In 1 Peter 3:15, Paul writes, "But in your hearts revere Christ as Lord, always prepared to give an answer to everyone who asks you to give the reason for the hope that you have, but do this with gentleness and respect." So maybe some of the things we'll talk about this week and the next weeks won't directly impact you, but maybe they'll impact a friend or a colleague or a family member who's struggling with some of these questions. Can I be a thinking person and a Christian? Hasn't science made the belief in God unnecessary? And so maybe, this will be a help. I want to talk about three things this morning. What do modern scientific observations say about God and the place of humans in the universe? This is a kind of talk that I would actually give at universities. I've given this talk or something similar to many universities throughout the world. And it kind of is a look at science and what it says about God. So we're going to do a little science this morning. If that's not your thing, bear with me. But you're hopefully going to learn a few things and see some things maybe in a different light. And we're going to talk about, trivial things like the origin of the universe and stuff like that. All right, just, minor issues in the world. Okay, so the first thing I want to talk about is the origin of the universe. Psalm 19:1, David writes, "The heavens declare the glory of God, and the skies proclaim the work of his hands." So let's ask the question, what do I see when I look in the heavens? Do they really proclaim God's glory? Do they proclaim God's glory simply because they look wonderful, or is there something even deeper than this? And of course, scientists study and look at the things that are deeper. And so as a scientist, we're going to go a little deeper and ask, what do we see when we look at the heavens? And how do they declare God's glory? Well, if you lived prior to 1929, the idea was that the universe was eternal. It had always existed. It was infinite in size. But in 1929, an amazing thing happened. Edwin Hubble discovered that the universe was expanding. So this is kind of like raisin bread expanding. This is the raisin bread model of the universe, all right? And notice how it expands. All of the raisins get farther apart from each other. Well, what Hubble noticed is that all of the galaxies in our universe are getting farther apart from each other. The universe is expanding. Now, you don't have to be a rocket scientist. Well, Hubble was a rocket scientist, but you don't have to be a rocket scientist to realize that if the universe is expanding, you can run the film backwards. It must have at one time started to expand. And if the universe started to expand, it means that maybe it had an origin. Now, scientists didn't really like that idea, because if it had an origin, it might have had an originator. And so you read statements like this shortly after Hubble saw that the universe was expanding. Arthur Eddington wrote, "Philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole." And the reason it's repugnant is because it points to a creator. Because if the universe had an origin, then something had to start it. So scientists were reluctant to accept this idea. We now call it the Big Bang. But unfortunately, or maybe fortunately, the evidence for the Big Bang just snowballed. It became greater and greater. There are three primary evidences as to why scientists believe that the Big Bang is the origin of our universe. First of all, as we said, the universe is expanding, so it must have had a time it started to expand. The second thing is called the temperature of the universe. Suppose you were to go to your home and turn your oven on and get the oven really hot. And then you turn the oven off and open the door and let that heat dissipate throughout the house. Well, a few hours later, the house would be a little bit warmer because the oven at one time was very hot. So in our current model of the origin of the universe when it started was very, very hot. And we should still see that heat today, and we do. It's called the cosmic microwave background radiation. And this is a picture of the whole sky and temperature fluctuations in it. But this looks exactly like what we would expect if the universe was at one time very hot and very dense, as predicted by the Big Bang. And then finally, the third piece of evidence that convinced scientists this was true is what we would say the light elements in the universe. Basically, the amount of hydrogen and helium in the universe is predicted to 1 part in 10,000 compared to what we actually see. So these kinds of things convince scientists that the Big Bang is the origin of the universe. Now, the Big Bang's kind of a misnomer. If you think about that term, it kind of implies that something exploded, a Big Bang. But in fact, a better explanation of the Big Bang is that it's the origin of everything we know in the universe: space, time, matter, and energy. It's the beginning. It's the origin. It's not an explosion from something that was there. There was nothing there. Even space and time itself seems to have had a beginning at the Big Bang. So that creates a problem if you think about it, and particularly if you don't believe there's a God. And this problem has been written about a lot by scientists. The biggest problem with the Big Bang theory of the origin of the universe is philosophical, perhaps even theological. What was there before the bang? So here's the point. If the universe had an origin, as the evidence seems to suggest, then the cause of this universe must be transcendent, not a physical part of the universe. Now, have you heard that idea before? That the cause of the universe is outside of this universe? That the cause of this universe is transcendent? Is that exactly what the Bible says? In the beginning, the transcendent God, who's not a part of this universe, created the heavens and the earth. And scientists understand these theological implications. Robert Jastrow wrote, this is my favorite quote of all, "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the rock, he's greeted by a band of theologians who have been sitting there for centuries." Right? So science, in all of its wisdom, comes to the very same conclusion that the Bible came to long ago, in a few things. First of all, that the universe had a beginning. The very first verse of the Bible, in the beginning, God created the heaven and the earth. It's only in the last 100 years that science has affirmed that truth, that the universe had a beginning. It's pretty remarkable. The second thing, I like this, the stuff of the universe did not exist at one time. The writer to the Hebrews says, "We understand that the universe was formed at God's command, so that what is seen was not made out of what was visible." He wrote that with no idea of, other than the inspiration of God, what the universe came in, how the universe came to existence. But he said it's made out of stuff we don't see. And now we know that. The space, the time, the matter, the energy of this universe all had a beginning. And then finally, that the Creator himself is transcendent, not bound by space and time. And Paul wrote that God was active before the beginning of time. Grace was given us in Christ Jesus before the beginning of time. It's interesting that out of all the holy writings in the world, only one writing actually explicitly talks about God acting before time, and that's the New Testament, the Christian writing. And so only recently has science begun to understand that time actually had a beginning. But Paul, realizing God's transcendent nature, said that God was active even before the beginning of time. Right? So the origin of the universe implies a transcendent cause that looks a lot like the God of the Bible. That's the first evidence from science that I want to talk about. The second is the design in the universe. Paul wrote in Romans 1:20, "For since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen, being understood from what has been made, so that people are without excuse." God's invisible qualities should be seen by looking at nature. And what I want to talk about, the design in the universe, shows so many of God's qualities. It shows his intellect. It shows his creativity. It shows his power. This is sometimes called the Anthropic Principle. It's that the universe appears to be designed. Many of the parameters in the universe seem to be precisely tuned to allow humans to exist. It's as if I have a nuclear control panel or something here, and I have 100 knobs. And if I turn any knob just a little bit, one way or another, instead of ending up with a universe that's hospitable to life, I end up with a universe that's inhospitable to life. Probably the definitive book on this is the Anthropic Cosmological Principle, written many years ago now. It's really thick, and it's a really good book, but it's really challenging. Unless you consider calculus as light bedtime reading, you probably don't want to read it. But in this book, Barrow and Tipler list over 100 of these knobs that if you just turn a little bit one way or another, you would get a universe that's inhospitable to life. And I want to talk about a few of these knobs. I'm not going to talk about 100 because I have to be done in 15 minutes, but we'll talk about a few things that, what are these knobs that are set perfectly? Well, one is the strength of the strong nuclear force. And I like this one because this is what I've spent most of my life studying. As we said, atoms are made of nuclei, and nuclei are made of neutrons and protons are made of quarks. And the strong nuclear force binds quarks together in the neutrons and protons and ultimately holds the nucleus together. It's because of the exact position of that knob, the strength of the strong nuclear force, that we have the periodic table we do. If I was to turn the strong nuclear force knob just 2% stronger, so I just take the knob and make the strong nuclear force 2% stronger, it would eliminate hydrogen from this chart. Now, we could lose one element, maybe that's not a big deal, but it is a big deal, right? Water is H2O. If you don't have hydrogen, you don't have water. The sun burns hydrogen. If you don't have hydrogen, you don't have stars like the sun. So if you take the strong nuclear force and turn it 2% one way, you get a universe that's inhospitable to life. Suppose I was to turn it the other way, 5% weaker. Well, if I made it 5% weaker, the periodic table would have only one element, hydrogen. Now, that'd make chemistry class really easy, right? But it would not make the universe hospitable to life. Right? So that's the strength of the strong nuclear force. Another interesting parameter is how carbon is formed. So we're all made of carbon. Everything that we know that's living is made of carbon. Where did that carbon come from? Well, stars have a lifetime. They're born, they live for a while, and they die. And one of the last things they do as they die is create carbon. The carbon in your body, according to modern scientific understanding, came from the debris, the leftover burned out debris of dying stars. So we're all made of stardust, basically. Yeah, this is from the Hubble telescope. It's the supernova remnant, which is the creation of carbon. So the creation of carbon is really a very challenging process. It goes through a bunch of steps which are called nuclear resonance states. And if any of those states were actually changed just a little, there wouldn't be any carbon around. Scientists have marveled at this. Owen Gingerich wrote, had the resonance level in the carbon been 4% higher, there would essentially be no carbon. Had the level in the oxygen been only 0.5% higher, virtually all the carbon would have been converted to oxygen. Without that carbon abundance, neither you nor I would be here tonight. So in other words, you take this little knob of nuclear resonances and you tweak them one way or another, and there is no carbon, and there is no life. This has been studied more. I like this because Dean Lee and some of his collaborators understood that this carbon is created because of the mass of the quarks inside a proton, which is what I've spent most of my life studying. So now we find that if you make a 2 or 3% change in the light quark mass, so I'm going to take those things that the proton is made of, I'm going to just tweak the knob 2 or 3%, so that their mass, how much they weigh, just changes by a little bit. And what you see, it would lead to problems with the abundance of either carbon or oxygen in the universe. Right? The universe is really precisely tuned. It's as if someone designed it so that we could exist. Now, I only mentioned 2 things, the strong nuclear force, the formation of carbon, but there are about 100 similar parameters that are finely tuned to allow life to exist. And scientists say things about this. Fred Hoyle says, such properties seem to run through the fabric of the natural world like a happy thread of coincidences. Who would ever think a scientist would write a happy thread of coincidences? But there are so many odd coincidences essential to life that some explanation seems required to account for them. Paul Davies, a physicist, writes, there for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. By the way, these people do not believe in God that I'm quoting. They're agnostic or atheists, but they still see the evidence of God. Romans 1:20, it's clearly evident so that they are without excuse. So that's the tuning of the universe, the Anthropic Principle. Finally, I want to talk about something called the rare earth. Are humans important? Does God care about them? Well, the Bible says yes. Psalm 8 says, when I consider your heavens, the work of your fingers, the moon and the stars which you have set in place, what is mankind that you are mindful of them, human beings that you care for them? You've made them a little lower than the angels and crowned them with glory and honor. Now, you might think that humans are not special. Science tends to say they're not special. Scientists tend to say that the Earth is not special. There are a lot of planets out there. But I want to ask the question, what's really required in order to create a planet like the Earth? So bacteria can probably thrive everywhere. But higher life forms, things more complex than bacteria, cockroaches, for instance, they require something more. Now, you'll often read in the newspaper that scientists have found another Earth-like planet. But they don't really mean Earth-like planet. They mean maybe the planet might have water on it, or maybe it might be rocky. Mercury's rocky, it's not really Earth-like. Or maybe it might be about the same size as Earth, which Venus is, but it's not really Earth-like. So what would it take to make a real Earth-like planet? Well, you have to be in the right galaxy. We live in a spiral galaxy. So these little swoops are stars, 100 billion stars in our galaxy or more. And about 10% of the galaxies in the universe are spiral galaxies. The other kind of galaxies would not be able to support higher life forms. And you can't live anywhere in the spiral galaxy. You have to live from about 1/3 of the way out to about 2/3 of the way out. Close to the center of the galaxy, there's too much radiation. Far from the center of the galaxy, there's not enough heavy elements. So where's our sun? right smack in the perfect place. It's called the galactic habitable zone. So you have to be in the right galaxy, at the right place in the right galaxy if you want a planet like the Earth. You also have to have the right kind of star. Our sun is called a Class G star. It's one of the few stars that burn really stable for a long period of time so that you could have a planet like the Earth around it. It's also what we call a third-generation star. In other words, the stuff of our sun was made after 2 generations of stars lived and died, and the leftover debris from the second generation was used to form our sun. It's actually kind of interesting. If any of you watch science fiction or read science fiction, Carl Sagan wrote a book called Contact that was made into a movie. And in that movie, Contact, the question was posed, well, the universe is so big that there must be other life out there. Humans probably aren't special. And I don't know if there's life out there or not. The universe is big. But the question should not be, why is the universe so big? The question really should be, why is the universe so small? So let me explain that to you. As the universe gets older, it gets bigger. Well, what's the shortest amount of time it would take to create a planet like the Earth? Suppose you started with a Big Bang, and you want to ask what's the shortest amount of time it would take to create a planet like the Earth. You have to go through 2 generations of stars to make the stuff for the planet Earth. And so our Earth was formed about 10 billion years after the Big Bang. That's the shortest amount of time it would take to create a planet like the Earth. Now, since the universe gets larger the longer time takes, if it's the shortest amount of time to create the Earth, it's also the smallest universe it takes to create the Earth. So in spite of the fact that this universe is huge, it's actually the smallest universe, believe it or not, you could have and have one planet like the Earth. The question isn't, why is the universe so big? The question is, why is the universe so small? It's as if it was meant to create a planet like the Earth. It's just this exact size it would take, and that's because the sun is the 3rd-generation star. There's so many factors about the Earth that make it just right. Everything from its tilt, to its rotation, to its size, to the amount of water, to tectonic activity. And if you take any of those things away, you don't have a planet that's hospitable to life. It requires more than just liquid water. The single large moon we have stabilizes the tilt of the Earth. If we didn't have a single large moon, the Earth would wobble like a top, and it would make life inhospitable, or the Earth inhospitable to life. The planet Jupiter is so huge, it's got so much gravity, it acts like a big vacuum cleaner, sucking up asteroids and all that might hit the Earth. So everything about our solar system is set up to create a planet like the Earth. Peter Ward and Donald Brownlee write in this book, Rare Earth, if some godlike being could be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden, that power would face a formidable task. It is unlikely that Earth could ever be truly duplicated. Does God care about humans? Well, he cares enough to make a place that's unlikely that it could ever be duplicated so that we could have a home to live in. Right? Now you can ask a question, well, can't you find other Earth-like planets? And you can do what we call in physics a back-of-the-envelope calculation, just a rough estimate as to how often might you find a planet like the Earth. Well, it's got to be in the right galaxy, that's 10%. You have to have the right star, that's a 20%. And you can kind of list the things that we've talked about that are required for a planet like the Earth. This is just a partial list. Let me give you the full list. There's the full list. Okay. One astronomer has come up with 322 parameters that are required to create a planet like the Earth. So if you read the news and they found a planet like the Earth, it means there might be water on it. That's one of these 322 things. And again, these numbers aren't exact, but they're close. There are lots of planets in the universe, probably at least 10 to the 22. But you can still do the math. The probability of finding one Earth-like planet is 10 to the minus 282. Now, in science, we have a technical term for that. It ain't going to happen. Okay? It's just not going to happen. So what do scientists say? A common-sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Alan Sandage writes, I find it quite improbable that such order came out of chaos. There has to be some organizing principle. God to me is a mystery, but is the explanation for the miracle of existence, why there is something instead of nothing. Now, I want to point out that scientists know this is improbable, and they come up with some ideas. Barrow and Tipler, in their book, believe that humans are the only intelligent life in the universe, and that the universe requires some intelligence to start it. So I got a problem for you. If humans are the only intelligent life, and there's no God, and the universe requires intelligence to start it, who started the universe? Well, Barrow and Tipler's idea is that humans will evolve to the point that they become like gods, and humans themselves will then reach back in time and start the universe for themselves. Right? So I have a picture of that. Right? It's kind of something like this. Okay. Photoshop. That's not really how Michelangelo did it, right? Okay. So that's kind of bizarre. Other scientists have proposed that maybe there's a whole bunch of universes. We just happen to live in the right one. There's only one that could support life, and we happen to be in it. Of course, there's no evidence for the other universes. It's just speculation. Some people think maybe there's a God. What's the most likely? An infinite number of universes we may never know about? Humans reaching back in time to start the universe for themselves? Or that there really is a God? And even the infinite number of universes doesn't preclude the fact that God would do it that way. We don't know. So how strong is the scientific evidence for God? Those who best understand it but choose not to believe in God come up with these ideas. Humans evolved to be godlike beings who reach back in time and create the universe for themselves. Or there are so many undiscovered and undiscoverable universes that one must have intelligent life in it. So these ideas really aren't science. They kind of masquerade as science. But they're because of a pre-commitment to scientism, that the only thing is science. The only thing is nature. And there's the difference between science and scientism. Scientism says that there's only one way to gain knowledge, and that is by observing the universe. But that's a philosophical statement, right? You can't prove by science that science is the only way to gain knowledge. So it's a philosophical statement. And it's really not a very strong statement, because if God exists, and if there is a supernatural realm, then scientific methods are not the only way to know things. And that's what we believe. In fact, many of you know there's a supernatural realm because you know God personally. I had a student who heard a talk like this. He was an atheist. He became a Christian. And I asked him, how important was this scientific evidence for God in your discovering Christ and becoming a Christian? He said, well, before I was a Christian, it was really important. It led me to become a Christian. But now I know Christ personally. Now I have a better way to know the truth. When you have a personal relationship with someone, you know that it's real. And so these kinds of facts led him to becoming a Christian. Let me just briefly talk about this. Is this a God of the gaps argument? A God of the gaps argument is an argument that says, well, we don't understand something, so God must have done it. We don't understand how protons fit together in the nucleus, so God must do it, or something like that. God of the gaps arguments are really, in general, poor arguments, because when you fill the gaps, you don't need God anymore. And we're going to talk a little bit more about that next week. But the things I'm discussing now are not things we don't understand. They're not God of the gaps arguments. They're things we do understand. We do understand the nuclear resonance states. We do understand the strength of the strong nuclear force. And they all seem precisely tuned as if somebody made them. Now, we don't understand, this is a little technical, we don't understand the very beginning of the universe. It's hidden from us. So if you don't believe in God, you can kind of fill that very beginning in and say, well, everything we see looks as if God did it. But since I don't believe in God, there must be something in that very precise moment it started that takes God out. I call this an atheism of the gaps. Everything that we see from almost the moment of creation at the universe till now looks like the universe is designed, like humans have a place, like it had a real beginning. But if you're an atheist, you don't like those conclusions. So the one place you can hide is in that first 10 to the minus 35 seconds and try to fill it with something that takes God away. And you'll read lots of times scientists have come up with a new theory of the origin of the universe. It's really not new. It really doesn't change the things we know. It's what happened at the very moment, the very beginning of creation. And people are looking still for outs. How can I get away from this idea that God did it? So what if the universe is design? Paul Davies wrote a remarkable statement. If physics is the product of design, the universe must have a purpose. And the evidence of modern physics suggests strongly to me that the purpose includes us. which is exactly what King David said, that the purpose of the universe includes us. He marveled at it. When I consider the heavens, the work of your fingers, the moon and the stars which you have set in place, what is man that you are mindful of him, the Son of Man that you care for him? And Zephaniah wrote that God will take a great delight in you. God cares about people, and we see that when we look at the planet Earth. So the bottom line is that the message of the Bible is that this transcendent God who created the universe cares about us. He sent Jesus into the world to come out of his transcendent nature, to become human, so that we could have a relationship with him. It's not just that he's transcendent and created the universe, is that he cares enough about humanity that he sent Jesus so that we could have a personal relationship with him. That's how important, we are to God. This idea has driven some scientists to believe in God. Alan Sandage wrote, "It was my science that drove me to the conclusion that the world is much more complicated than science. It's only through the supernatural that I can understand the mystery of existence." So what I like to conclude with is this: the discoveries of modern science, they don't lead us away from God. They actually lead us towards God. They lead to an abundant evidence for the existence of a transcendent, intelligent designer who created the universe, has a purpose for humanity. And that's in exact agreement with what the Bible says. So that's where we'll stop for this week. Next week, I'm going to talk about the Bible and some controversial things like Big Bang and evolution, and we'll all get in a big fight at the end, and it'll be really wonderful. So come back next week and hear about some of these fascinating but yet maybe controversial things. Thanks for coming.